All right, so the number of bacteria in a dish, N, after T minutes is given by that. So A, we have when T is 0, so that's just going to be 800 e to the 0, which is just 800. For B, find the rate at which N is increasing when T is 15. So if I'm doing this in the calculator, you need to just be on a calculator screen and do menu, calculus, numerical derivative at a point, and then your variable is x or t, whatever. I'm just going to leave x. The value they want to add is 15, and the derivative is the first derivative. So then you get d dx, and you just type in your function, which is 800 e to the point, I suppose that's 0.13 times x, and then enter. So you should get 730.984. So C, after k minutes, the rate of increase, so remember k is going to be t, the rate of increase in N is greater than 10,000 bacteria per minute. So we have N at T, so the rate of increase, so that's the derivative, is greater than 10,000 bacteria per minute. Find the least value of K. So this one the calculator can't do. We have to find the derivative, which is 800 e to the 0.13 t times 0.13. And then in the calculator, you can n solve to see when, to see what t is equal to. And that's right when the rate of increase is equal to 10,000. So after that is going to be when it's greater. So you should get 35.1227. So K rather is going to be 36 minutes. Okay, 26, an experiments carried out in which the number of bacteria in a liquid is given by that. T is minutes from the beginning of the experiment and K is constant. The number of bacteria doubles every 20 minutes. So for A, if we have N at 0, that's going to be 650 because it's going to be e to the 0. And then 20 minutes later, we're going to have that it's 1300 e to the k times 20, because 20 minutes later it's doubled. Okay, so then you can n solve for k, except not because they want exact value. So we are going to do 1300 divided by 650 is 2, e to the k times 20. Write this natural log. So we're going to have natural log of 2 equals k times 20. So we're going to have 1 over 20. Natural log 2 is k. So the rate at which the number of bacteria is increasing when t is 90. So we want the derivative at 90 minutes. And so first we have to find the derivative, which is 650 e to the 1 over 20 natural log 2 t times 1 over 20 natural log 2, because that's just a constant. That's just a number. So then we can substitute 90 in there. I don't know how they want this without a calculator. So we're going to have, first of all, I'll cancel the tens. So we're going to have 65 over 2 natural log 2, and then e to the 1 over 20 natural log 2 times 90. I think this has to be in a calculator. So in the mark scheme, they give it as a decimal, so it must be. And so I would have done numerical derivative there with the calculator from the beginning if I'd have known. Okay, so we've got f at 1 is 2, the derivative at 1 is 4. Find the derivatives of the following functions at x equals 1. So if we want the derivative of I, we're going to have y prime is 2 f at x. This is a function, so to the 1 times the derivative of the function, okay? So chain rule. And for double I, we've got y prime is going to be the derivative of the function at x squared. So that's the derivative of the whole thing, and then times the derivative of the inside function. Okay, so now we want to add 1. So this one's going to be 2 times f at 1. I'll just write it out. Times the derivative at 1. So 2 times 2 times 4, which is 16. And this one is f prime at 1 squared, which is 1 times 2 times 1. So derivative at 1 is 4 times 2, which is 8. Okay. So I think this is right. I don't think the mark scheme is right. Let me know what you think. Mark scheme says 4. All right, 28. We're going to have the derivative is 3 f at x squared times the derivative of f at x. And for double I, we want the derivative of the whole function times the derivative of the inside, and we want to add 1. So 3 times f at 1 squared times the derivative at 1. So this is 2 squared times 4, so 12. This should be 48. And then this one is going to be the derivative at 1 cubed, which is 1, times 3 times 1 squared. So derivative at 1 is 4 times 3, which is 12. I think I'm right again. This is what they say in the mark scheme it's 6, but I think I'm right with 12. Let me know. All right, so for I, we have 1 over f at x times the derivative f at x. So then we have 1 over f at 1 times the derivative at 1. So this is 1 over 2 times 4, so 2. Okay, and then we have for double I, the derivative. Okay, so if we rewrite this as f at x to the 1/2, the derivative is going to be 1/2 f at x to the negative 1/2 times the derivative. So if we want y prime at 1, we have 1/2 f at 1 to the negative 1/2 times the derivative at 1. Okay, so this is going to be 1 over 2, and then this is the square root on the denominator of 2, then times the derivative at 4. So this is going to be 2 over root 2. So that one I got right. All right, 30. The following table shows f and g. Okay, so find the derivative. So for a, we have to do quotient rule. So we're going to we start with v. So, and you have v down here. Oops. And then that's squared. So you have v times the derivative of u, which is 3 f prime at x, minus u times the derivative of v, which is just g prime. So now we want at 0. So g at 0 is negative 4 minus 1. 3. The derivative of f at 0 is 1. F at 0 is 4, and the derivative of g at 0 is 5. And then we have g at, so this is going to be negative 4 minus 1 squared. So then this is negative 5 times 3, which is negative 15, minus 60 over negative 5 squared, 25. So this is going to be negative 3. Okay, so B, F, okay, so we need the derivative of the whole thing times the derivative of the inside function. So that's g prime at x plus 2. So now, okay, so now we need f prime. So g prime at 1 is 2. No, g at 2. G at 1, sorry. G at 1 is negative 1. Plus 2 times 1, which is 2. Times. Okay, now we have g prime at 1, which is 2, plus 2. All right, so now we have f prime at 1. F prime at 1 is 3 times 4, which is 12. All right, 31 for the function. Find the possible values of sine x for which the derivative is 0. Okay, so we need to find the derivative. So we're going to have 1/2 cosine 2x times 2, which cancels, minus sine x. And we want this equals to 0. So we need to switch cosine 2x to a sine. So 1 minus 2 sine squared x minus sine x equals 0. And then switch the signs, the SIGNs. And then we have 2 sine x and sine x. And 1 and 1. And we need a positive 2 minus 1. And that's equal to 0. So we have sine x is 1 over 2. Okay, so, and sine x is negative 1. This is A, because they just want sine x equals whatever. What can sine x be? Now, from negative pi to 2 pi, so negative pi is this way. So sine isn't 1/2 or 1 there. However, going this way, yes, we can have some answers here. So sine is 1/2 here and here at pi over 6 and 5 pi over 6. And sine is 1 at pi over 2. They're also saying that, oh, did I do it wrong? Yes, I did. This is negative 1. Okay, so this is actually, it's not up here. So it's negative pi over 2 when we do from 0 to negative pi. And then when we go this way around, it's 3 pi over 2. So those are your answers. Oops. Okay, 32, we've got this function. Find dy dx. So for A, dy dx is going to be the first times the derivative of the second, pi x, times pi, because of chain rule. And then plus the derivative of the first, which is 3e to the 3x, times the second, which is sine pi x. Now B, find the smallest possible positive value of x for which dy dx is 0. Okay, this is without graphing calculator. So first of all, we can factor out an e to the 3x. And then on the inside, we're going to have pi cosine pi x plus 3 sine pi x equals 0. Now, this e to the 3x is never 0, so there's no solution for that. However, we can maybe work with this. So if we get sine to the other side, so if we just do negative, and now I'll have pi over negative 3, negative pi over 3, and then, oops, oh my goodness. So I'm just writing weird things. This is an x. Okay, so now I'm going to have sine pi x over cosine pi x, which is tangent pi x. Oh my gosh. Okay. So now we have tangent. So they don't give us a domain. We just have to find the smallest positive. So tangent is negative pi over 3. Hold on. Yeah, again, we have to use calculator. So if we do the inverse tangent of negative pi over 3, and then make sure your calculator's in radians. So that ends up being negative 0.808449. And then, so if you think about that, tangent's negative down here. So it's like this is that radians, okay? So, and remember, tangent has a solution every pi k, where k is just an integer. So this equals pi x. So now if we divide by pi here, we're going to have that thing plus pi k over pi is k. Now, if we divide that thing by pi, that's still a negative number. And if I add 0 to it, that doesn't change anything. Remember, k is an integer. So if I add 0 to it, that does nothing. So if I add 1 to that, that should be our answer. So k equals 1, x is 0.743. All right, 33, we have the derivative of f is going to be, so remember this is cosine 4x plus 1 cubed. So 3 cosine 4x plus 1 squared, what I put there, times the derivative of the inside function, which is negative sine 4x plus 1, times the derivative of the most inside function, which is 4. Okay. Now, find the exact values of the 3 roots of f prime at x equals 0. Okay. So let's just rewrite this 12, negative 12 rather. Cosine squared, 4x plus 1, sine 4x plus 1, and this is going to equal to 0. So divide by negative 12, 0. So now we're going to have cosine squared 4x plus 1 equals 0, and sine 4x plus 1 equals 0. So if we square root for the cosine, square root of 0 is just 0. All right, so now cosine is 0, and this is 0 to 1. Cosine is 0 at pi over 2, which is over 1. Oh, we can change the domain. Gotcha. Okay, so if we do times 4 and plus 1, Okay, so now we're 1 to 5. All right, so now we can do 4x plus 1, cosine of 0 at pi over 2, and 3 pi over 2, but yeah, that's still in the domain, so 3 pi over 2, and that's almost 5, so those are those two answers. So we will subtract 1 and divide by 4. So we're going to have pi over 2 minus 1 over 4. That's 1. And then 3 pi over 2 minus 1 over 4. Now sine is 0 at 0, which is outside of our domain. And it's also 0 at pi. So x is going to be pi minus 1 over 4. So, ooh, those should be our 3 answers. Okay. Okay, 34. F at x is that, find the derivative. So start with v, top and bottom. And then times, so v times the derivative of u, which is 2x plus 5, minus u times the derivative of v, which is just 1. Okay. So solve f greater than, so we want this greater than 2. All right, so if we subtract 2, so we're minusing, we have to make the same denominator. So we want to know when that's greater than 0. Okay, so now we have to do all of this out, combine everything, and see if we can factor and stuff. Okay, so we're going to have 2x squared plus 5x plus 4x, which is plus 9x plus 10. Then minus x squared minus 5x minus 5. And then minus 2. And then this is x squared plus 4x plus 4. So we're going to have minus 2x squared minus 8x minus 8 when we distribute the negative 2. Don't do the denominator. So then we're going to have 2x squared minus 2x squared. So we're just going to have a negative x squared. And then we're going to have 9x minus 5x, which is 4x, minus 8x, which is negative 4x. And then we're going to have 10 minus 5, which is 5, minus 8, which is negative 3. All right, so if I were to factor a negative out of here, so plus, 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 and a negative would be here, and then I can divide by negative 1, so that's going to switch our inequality around, okay? X plus 2 squared. Okay, so then that thing up top factors to x plus 3, x plus 1, and now we've got our number line. So we've got negative 3, which it can't be, negative 2 from the denominator, which it also can't be, and negative 1, which it also can't be. So now we have to find, so we have to test points and see when it's less than 0. So negative 4, well, the bottom's always positive, so we just care about the top. So that's going to be a negative times a negative, so this is positive. Negative 2.5, it's going to be a positive here and a negative here. So this is negative. Negative 1.5 is going to be a negative and positive again. So that's a negative, and 0 is going to be a positive. So we want in between negative 3 and negative 1 to be our answer. Okay,